Good day everyone, welcome back to our discussion on the topic integration. Today we'll be treating trigonometric functions. Now, we've able to derive some of the derivative of our trigonometric function, and we know that integral is the opposite of differentiation. So in integrating trigonometric function, we try and just reverse what we've done in differentiation. So here is a table of different integral, and I will be going through them for clarification. The number one is this integral of s to the power n ds, which is our general integration formula, and it is s to the power n plus 1 divided by n plus 1 plus c. Now number two is the integral of 1 over s, and the answer is ln s plus k, because recall, when you differentiate ln s you get 1 over s. So therefore, when you integrate 1 over s, it's going to give you ln s back, and since it's integration, we are going to be adding our constant of integration. Now the next number is number 3. It says that the integral of e raised to power s. Now when we differentiate e raised to power s, we got e raised to power s. So when we are integrating e raised to power s, it is definitely going to give us e raised to power s. So the integral of e raised to power s ds is equal to e raised to power s plus k. Number 4 is the integral of a raised to power s ds. This is going to give us a raised to power s divided by ln a plus k. Remember, when we differentiated a raised to power s, it gives us a raised to power s ln a. Now we got a raised to power s, but it was now multiplied by ln a. So in the reverse, we are dividing by ln a, so that when it cancels out, it will still be the same function. So the integral of a raised to power s ds is a raised to power s divided by ln a plus c. Number 5, the integral of sin s is minus cos s. Remember, when we differentiated cos s, it gave us minus sin s. So when we are integrating sin s, it's going to give us minus cos s because of the sign. Number 6 is the integral of cos s is sin s plus our constant. Remembering, when we differentiated sin s, it gave us cos s. So therefore, when we are integrating cos s, it's also going to give us sin s, since it's basically the reverse. The next is the integral of sec square s, which is tan s, because when we differentiated tan s, it gave us sec square s. Number 8, the integral of cosec square s is minus cot s, because when we differentiated cot s, it gave us minus cosec square s. So I believe we are seeing the pattern here. Number 9, the integral of sec s tan s is sec s, because when we differentiated sec s, it gave us sec s tan s. And the final number 10, the integral of cosec s cot s is minus cosec s, because when we differentiated cosec s, it gave us minus cosec s cot s. So basically, when we integrate trigonometric function, we try our best to memorize and remember most of the integral from this table. So it's simple as just remembering it and putting your final answer when you are integrating. Other functions that did not fall in this category are simply integrated using other methods, but for this set, you can just integrate them by remembering that, okay, when I differentiated minus cos s, or when I differentiated cos s, I got sin s. So if I'm integrating sin s, it's definitely going to give me cos s. There is no need to prove it, there's no need to try and solve it out. You know that, okay, integral of cos s is going to give me sin s. We are going to be trying some questions applying this. Our first question is from WAEC 1997. It states that integrate 1 over s plus cos s with respect to s, and we are given the option. Now the very first thing is to write down our equation. The integral of 1 over s plus cos s in bracket ds, this will be equals to the integral of 1 over s ds plus the integral of cos s ds, since we are going to be integrating every component individually. Now from our table in the previous slide, we know that the integral of 1 over s is ln s, and the integral of cos s is sin s. So therefore, our final answer will be equals to ln s plus sin s plus k. we are definitely going to be adding our constant of integration. Our next question is from Neko, and it states that integrate tan square s, and we are giving the option. Now, from our table, we are not giving the integral of tan square s, so we are going to be using trigonometry or trigonometry identity to simplify tan square s to a form in which we can integrate it. And remember, we know that from our trigonometric identities, tan square s is equals to sec square s minus 1. So we'll be splitting tan square s equals to sec square s minus 1. So therefore, the integral of tan square s ds will be equals to the integral of sec square s minus 1 in bracket ds. Now, expanding our bracket and splitting, it will be equals to the integral of sec square s ds minus the integral of 1 ds or the integral of ds. From our table of integral trigonometric function, we know that the integral of sec square s is tan s, and when we integrate the s, it's going to give us s. So therefore, our final answer will be equals to tan s minus s plus c, and the correct option is A. We have another question from Neko. It states that evaluate the integral of e raised to the power of s minus sec s tan s in bracket ds. Now, the very first thing is to write down our equation, the integral of e raised to the power s minus sec s tan s ds. And since it's a polynomial function and is joined by minus, we are going to split it and integrate individually. So this will be equals to the integral of e raised to the power s ds minus the integral of sec s tan s ds. And from our table, the integral of e raised to the power s is also e raised to the power s, and the integral of sec s tan s is sec s. So therefore, our final answer will be equals to e raised to the power s minus sec s plus c, which is our constant of integration. We have another question that says that solve the integral of cos 2s ds. Now, this question falls under the category of change of variable. From our table, we know that the integral of cos s is equals to sin s, but that doesn't necessarily mean that the integral of cos 2s will be equals to sin 2s. Now, the way we go about it is to put 2s in a form of which it will have to be single, like cos a, cos b, and solve from there. So what we do is that we'll make 2s to be equal to another variable. In this case, we're making 2s to be equals to u. So let u be equals to 2s. Now, if u is equal to 2s, our equation becomes y is equals to the integral of cos u ds. And as you can see, we have two variables, which is u and ds. And to make our variable uniform, we have to find the du version. That we have to substitute ds for a variable that includes u. So to get that, we'll find du over ds. Du over ds will be equals to 2. Then we'll make the s formula by multiplying. Ds will be equals to du over 2. Now we can substitute ds to be equals to du over 2 in our equation that says that y equals to cos u ds. Substituting, y will be equals to the integral of cos u to du over 2, which you can simplify to be equals to the integral of 1 over 2 cos u du. Now we can bring our 1 over 2 constant out because we are not going to be integrating it. It becomes y is equals to 1 over 2 the integral of cos u du. At this point, we can easily integrate cos u because we know that the integral of cos u is sin u, and doing so, y will be equals to 1 over 2 sin u plus c. But recall that u is equals to 2s, and substituting u for 2s, our final answer y will be equals to 1 over 2 sin 2s plus c. We have another question similar to the question we just addressed. It's from UME. It states that evaluate the integral of sin 3s ds. Now, in our solution, we're writing down our equation y equals to sin 3s ds. And because we have 3s, we are going to be using integration by substitution. So let u be equals to 3s. Du over ds will be equals to 3, and ds will be equals to du over 3, because when we cross multiply, it becomes du over 3. So now we are going to substitute 3s to be equals to u and ds to be equals to du over 3 in our original equation. substituting, y will be equal to the integral of sine u du over 3, which is also equals to 1 over 3 the integral of sine u du. Now from our table of integral, the integral of sine u is minus cos u. So therefore y will be equals to 1 over 3 times minus cos u plus our constant of integration, which is c. Now recalling that u is equals to 3s and substituting u to be equals to 3s, y will be equals to minus cos 3s over 3 plus c. Here are some exercises for you to try your hands on at home. For more insight on this topic, you can check our Hidden Facts for Mathematics textbooks. You can get the hard copy at bookshops, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.